All right. So 1.5, properties of limits. So now we're going to look at some properties. So we have 8 in here. We will go over it one by one. Okay. Limit of a constant function. If we have limit of c as x approaches a, that is equal to c. So we have an example here. Limit of -1 as x approaches 3. So that is going to be equal to -1. It is like, you can think it as a horizontal line, right? So -1. So when x is 3, as you see, limit is -1. Okay. All right. So limit of a identity function, that is y equals x. The limit of x as x approaches a is a. You just kind of substitute a there. So limit of x as x approaches 3, when you sub, you get 3. Limit of sum or difference. If you have limit of f of x plus or minus g of x, okay, as x approaches a, so this can be written as limit of f of x as x approaches a plus or minus limit of g of x as x approaches a. So if we have limit of x plus 4 as x approaches -2, actually we can write this as limit of x as x approaches -2 plus limit of 4 as x approaches -2. So you already know how to do this from number 2, right? That will give you -2. And this part, limit of 4 as x approaches -2, that is number 1. So that is just 4. So you get 2 as an answer. So next one is limit of c times f of x as x approaches a. So this can be written as c times, c being a constant, okay? C times limit of f of x as x approaches a. So if you have limit of 2x as x approaches -1, we can write this 2 times limit of x as x approaches -1. So you know how to calculate this again from number 2, right? So 2 times, so you just sub -1, so you get -2 as an answer. The limit of a product, if you have a limit of f of x times g of x as x approaches a, okay, this can be written as limit of f of x as x approaches a times limit of g of x as x approaches a. Let's say we have limit of -x times 2x. So you can consider a -x as f of x, 2x as g of x. So we can write this as limit of -x as x approaches 1 times limit of 2x as x approaches 1. So you can actually, go further, and we already looked at this number 4, right? 2x. If there is a constant, you can move it to the front. You can even write this as 2 times limit of x. But then that gives you sub in -1. Even you could take the -1 outside. And 2 times you sub 1. So you get -2. So next one, that was the limit of a product. Number 6, limit of a quotient. If you have limit of f of x over g of x as x approaches a, this can be written as limit of f of x as x approaches a over limit of g of x as x approaches a. Okay, so of course this rule exists if limit of g of x as x approaches a is not equal to 0, because if it is equal to 0, then this becomes undefined, right? Then if we have limit of 3x minus 5 over 2x plus 4 as x approaches 1, we can write this as limit of 3x minus 5 as x approaches 1 divided by limit of 2x plus 4 as x approaches 1. Then actually you can, follow other rules and write this as limit of as x approaches 1, 3x, but I'm going to put the 3 in front. And limit of 5 as x approaches 1 over, same thing with the denominator, you can write it as 2 times limit of x as x approaches 1 plus limit of 4 as x approaches 1. Okay, so that will give you sub 1, 3 times 1, 3. That is 5 over sub 1, 2 plus 4. Oops, you can see. So negative 2 over 6 gives you negative 1 over 3. Limit of a power, if you have limit of f of x to the power of n as x approaches a, this can be written as limit of f of x as x approaches a to the power of n. N being any rational number. So example, limit of 3x minus 1 square as x approaches 1 can be written as limit of 3x minus 1 as x approaches 1 square. Right. So then again, you can do limit of 3x, which can be written as 3 times limit of x as x approaches 1 minus limit of negative 1 as x approaches 1 square. So that gives you 3. Oops, if I put negative 1 there, I should put positive 1 here. Okay, so that gives us 3 minus 1 square. 2 square is 4. Okay, finally, okay, so using all those 7 rules here or properties, we can say that limit of a polynomial, okay, we can calculate the limit of a polynomial by just substituting that value in the function, because all the polynomials are continuous functions and the value of the function is same as the limit for those continuous functions, okay, functions. So then limit of f of x as x approaches a equals f of a. Means, using all those rules, we can come up with a shortcut. Let's say if you have a parabola, x squared minus 3x plus 1, you can calculate the limit by just taking this value, negative 1, subbing in here. So this gives us negative 1 squared minus 3 times negative 1 plus 1. So 1 plus 3 plus 1, so it is 5. Most of the time, you won't need to use these properties, okay, but I needed to show it to you to come up with this rule. Identity function y equals x. Means it is same as x is same as y. Now we are going to look at some strategies when we are calculating the limits. One strategy would be simple substitution. Okay, so If you don't get 0 over 0 when you're substituting, then you have the answer right away. Okay, for example, here, if you substitute 2, so example 1, limit of square root of x squared plus 5 as x approaches 2, you can just sub in 2, so you get square root of 4 plus 5, which is 9, you get 3. As long as you don't get 0 over 0, then substitution method works. Okay. Yeah, let's say you have a rational function. Yes, this function is discontinuous at the vertical asymptotes, true, but actually they are continuous at other places. Okay, so again, when you substitute -1, if you don't get 0 for the denominator, then that is just fine, right? So -1 sub in -3 minus 9 over -2 plus 1. This gives you -12 over -1, just 12. We did not get 0 for denominator, or we did not get 0 over 0, so it is okay to use the substitution method. Now we're going to look at, yes, exactly. So you first try to do the substitution method. If you don't get 0 over 0 or a number over 0, then you can use the substitution method. That's perfectly fine. But if it doesn't work, and most of the time you will see that it will not work, then you will look at other strategies to calculate the limit. So one is, let's say, factoring. Another strategy, rationalizing the numerator or denominator. Another strategy, changing the variable. Okay, so those are some strategies to calculate the limits. Let's say we have limit of x squared plus 3x minus 4 over x minus 1 as x approaches 1. When you substitute 1, what do you get? So 1 plus 3 minus 4 over 1 minus 1. So you have 0 over 0. Means you cannot use the substitution method. Okay, but first you try if it is going to work. So when you get 0 over 0, then you say, okay, I have to use something else to calculate the limit. So one of the methods is factoring. So we can factor, let's say, numerator. So that gives us x plus 4, x minus 1 over x minus 1. Okay. So now you see that x minus 1 and x minus 1 can be gone here. Then you just look at the limit of x plus 4 as x approaches 1. Now you can use substitution, right? After this point, you just substitute in here. So you get 5. Another method, rationalizing the numerator or denominator. That is the whole reason actually we did 1.1, okay, to calculate the limit. So let's say you have, yes, the previous question, actually, see, if you were to sketch this function here, if you were to sketch, so you would factor. So you know that there is a hole at 1, okay? So you just sketch x plus 4. And then put a hole at 1, because there's a hole here, right, at 1. So this function would be this. Means the function is undefined when x is equal to 1. However, limit exists, right? You look at from left, you look at from right. limit is here, which is 5. But the value of the function itself does not exist. That is the reason when you sub in, you get 0 over 0, which is undefined. Okay. So again, another method is rationalizing the numerator or denominator. So let's say we have limit of square root of x plus 4 minus 2 over x as x approaches 0. Again, the first thing we want to do is substituting the 0. So when you sub 0, you get root 4 minus 2 over 0, which is 0 over 0. Now you see that substitution doesn't work. Can you factor it? Not really. So what are we going to do? We're going to use the rationalizing numerator or denominator method. So limit of square root of x plus 4 minus 2 over x. So we can rationalize a numerator. So multiply by conjugate. Okay, so what do we get? X plus 4 minus 2 square is 4 over x times, don't expand this, okay, so x times square root of x plus 4 plus 2. So in the numerator now, we have x over x times square root of x plus 4 plus 2. So you see x and x is gone. Limit of 1 over square root of x plus 4 plus 2 as x approaches 0. Now actually you can substitute 0. So you get 1 over square root of 4 plus 2. So that is 2. 2 plus 2 is 4. You get 1 over 4. As you substitute the x value, you don't write limit anymore. So be careful with that step. Okay? Until you substitute, you keep carrying the word limit. As you substitute, you do not use it anymore. Many students make mistake with that. Okay, so even they substitute, they still keep using the limit, which is not correct. As you substitute, you are calculating the limit. Or some people will forget, so they will write this step, and then they will forget to write the limit. That is also not correct. Okay, so you have to carry that limit word until you substitute. Okay. Another method is changing the variable. Usually students find this the hardest. Okay. So again, we have this limit of root x minus 1 over 4th root of x minus 1 as x approaches 1. So first you try to sub in. So what do you get? Square root of 1 is 1 minus 1. 4th root of 1 is 1 minus 1. So you get 0 over 0. So substitution did not work. Now what you do, right? So can you factor it? Well, you have the roots and stuff. This is factorable. You won't be able to see it right away. Okay, so it's not factorable, you will say. Then can you rationalize numerator or denominator? Well, if you did not have this, root of x minus 1, then that could work. Okay, if you had, let's say, x only here, then that could work. But in this case, you have 4th root of x and stuff, so that's not going to help you a lot. So what you do, we use another method, is called changing the variable. So for example, here, what I'm going to do, so I'm going to say that 4th root of x is u, Okay, I'm going to assign a variable for it. Fourth root of x is u. Then what would you get for square root of x? Okay, so fourth root of x is x to the power of 1 over 4, right? Then root x, which is x to the power of 1 over 2, would be what? So now we need to decide for that, okay? So x to the power of 1 over 2 is actually square of x to the power of 1 over 4. Therefore, x to the power of 1 over 2 is u squared. Now we can change the variable here, okay? Square root of x is, we said u squared. U squared minus 1. Fourth root of x is u, so u minus 1. Okay, so you replaced x by u, but what are you going to do with this x? You cannot have u here and x there, okay? So it means that you have to replace that x as well and make it u, all right? But then you have to calculate, calculate what u is approaching to. When x approaches 1, u approaches what? So you have to calculate that, okay? So u is fourth root of x, right? So we said u is fourth root of x. So when x approaches 1, u approaches also 1 in this case, okay? They are not always the same. They are not always approaching this to the same number. In this case, it was just a coincidence that x and u are approaching to the same number 1. But, for other questions, x may approach something and u may approach something. You have to calculate it to see what u is approaches to. Okay? So after you change the variable, you see that uh, this stuff now can be factorable, right? So limit as u approaches 1. So u squared minus 1 can be factored as u minus 1, u plus 1 over u minus 1. Okay. Now u minus 1, you can't see. Okay, so u minus 1 and u minus 1 is gone. So you get limit of u plus 1 as u approaches 1. Now substitute. So you get 1 plus 1, which is 2. Example 6. We have limit of 2x over x plus 27 to the power of 1 over 3 minus 3 as x approaches 0. Okay, so you first try substituting. So we get 2 times 0 is 0. And here, 0 plus 27 is 27. Cube root of 27 is 3. So you get 3 minus 3, which is 0, right? So now you see that again, we end up with 0 over 0. So substitution did not work. Factoring, it will not work. Rationalizing, numerator and denominator, will not work. Therefore, again, we're going to use changing the variable method. So in this case, so we're going to take, let's say this one, okay, x plus 27 to the power of 1 over 3. And we're going to assign a variable for it. Let's say u. Okay, then you get what? So limit in denominator. So x plus 27 to the power of 1 over 3 is u. So u minus 3. Okay, how about x, right? Now you have to check what x is equals to in terms of u. So now you can take the cube of both sides, okay? If you take the cube of both sides, Then you get x plus 27 equals u cubed. Okay. Then you isolate x, so you get u cubed minus 27. Okay, so I have 2x, so 2 times u cubed minus 27. But again, so I cannot write this part with u and keep the x here, right? We don't do that. We also have to change that to u. So now we have to calculate as x approaches 0, u approaches what, right? So we said u is x plus 27 to the power of 1 over 3. As x approaches 0, 0 plus 27 to the power of 3. So 27, cube root of 27 is 3. So u is 3. So as x approaches 0, u approaches 3. Okay. After you change the variable, you should notice that you still have 0 over 0. You did not change that situation yet. Okay. Yeah, so that could be your checkpoint. After you change the variable, you may substitute, let's say in this case 3, okay, and then see if you're still getting 0 over 0. You should be, if you did not make a mistake, because we didn't change anything yet. We just changed the variable, but we did not change the situation of 0 over 0 yet. Okay, so next point, of course, we're going to factor. Oh, by the way, you may have forgotten, I'm going to remind you the sum and difference of cubes formula. Okay. So let me write it here. Take a note, please, just in case. Okay. So x cubed minus y cubed is x minus y times x squared plus xy plus y squared. And x cubed plus y cubed is x plus y times x squared minus xy plus y squared. So we learned this in advanced functions, but just in case that you forgot, so take a note of those formulas. Okay, so u cubed minus 7 is u cubed minus 3 cubed. So we can factor it as u minus 3. So x squared, u squared, x times y, so 3 times u plus 9 over u minus 3. Now you see that u minus 3 and u minus 3 are gone. Means that you removed 0 over 0 situation by doing that. So you end up with 2 times u squared plus 3u plus 9. Now substitute 3. So 3 squared is 9. 3 times 3 is 9 plus 9, 27. 27 times 2, 50. Okay, sometimes you will see the absolute value in the functions, okay? So when you're calculating the limit. So how do we deal with that? If you directly substitute 1, what do you see? You get 0 over 0 again, right? But as long as you have the absolute value, you can factor it, you can use rationalizing numerator or denominator method, or even changing the variable method. So if you see an absolute value, actually we are going to check the limit from the left side and from the right side separately and decide what the limit is equal to, or if it exists. Okay, so now I want you to recall, okay, absolute value of x first. So absolute value of x is when x less than 0 is negative x, and when x is greater than or equal to 0, it is positive x. Okay, so let me sketch absolute value of x here quickly, just to remind you. Okay, so that is y equals absolute value of x. As you see, when x greater than or equal to 0, you get y equals x line. When x is less than 0, you get y equals negative x line. Okay. So then if you have, let's say, in this case, we have absolute value of x minus 1 here. So what can we say about that? Okay. And you know, it is x when x is greater than or equal to 0. And this is going to be when x is greater than or equal to 1, because 1 makes inside 0. Okay. So you get x minus 1. So when x is less than 1, since you multiply this by a negative sign, same thing here, negative x minus 1. Okay. And if you look at this function, y equals absolute value of x minus 1. That is 1 here. Okay. So this line, when x is greater than 1, is x minus 1. X minus 1. When x is less than 1, so you have this line, which is negative x minus 1. Negative in a bracket x minus 1, so that gives you negative x plus 1 actually. So the y-intercept is 1 there. Okay. So having said that, now we can look at the left side limit and the right side limit. The limit of this as x approaches 1 from left. When we look at the left side limit, so we are looking at where x is, let's say, you know, getting closer to 1 from left, let's say 0.9999. So then we are going to use this part and replace absolute value of x minus 1 by negative in a bracket x minus 1. Okay. And for right side limit, we're going to calculate that. But okay, so as x approaches 1 from right, okay, so means that, you know, we're getting closer to 1 from right side. Think a number, let's say 1.00001. So then we're going to use this interval here. Okay, so that gives us x minus 1. Okay, so left side limit, we get negative 1. And for the right side limit, 1, so that is equal to 1. So left side limit and right side limit, they don't equal to each other. So therefore, this limit is, it doesn't exist.